Hello everyone and welcome to Smart Brains Academy. I'm a first year student in the BIT program at UCSC. I'm really excited to share my knowledge and help you learn through this channel. To get you started, I'm offering the first class completely free right here on YouTube so you can get a feel for what we do. If you enjoy it and want to continue learning, the rest of the classes are available through a paid program. For the grade 7 ICT course, the fee is only 6,300. You can pay it in 3 easy installments. Once you join, I'll add you to my Google Classroom where you will get access to all the exclusive lessons. To join the paid course, you just need to make the payment and send me your email so I can add you to the class. The paid classes will be shared as private videos only accessible to enrolled students, so it's a safe and focused learning space. If you have any questions or want to get in touch, feel free to contact me at 077 217 6544. Thank you for stopping by. Don't forget to watch the free class, and if you like it, I'd love to have you join the full course. Alright, so let's get started. Central Processing Unit. Have you ever wondered what makes a computer think and work? Today, let's talk about the Central Processing Unit, or simply the CPU. What is the CPU? The CPU is the brain of the computer. It is the part that does all the thinking, calculating, and decision making. Can we see the CPU? No, you can't see the CPU from outside the computer. It is located inside the computer, usually on the motherboard, safely protected. Let's understand it with an example. Imagine a big hotel kitchen. The computer is like the kitchen. The CPU is like the chef. Just like a chef takes raw ingredients, cooks them, and turns them into tasty food, the CPU takes data, processes it, and turns it to useful information. What about speed? If the chef works fast, food is ready quickly. If the chef is slow, food takes more time. In the same way, a fast CPU is equal to a fast computer, a slow CPU is equal to a slow computer. Now, let's identify the central processing unit, also called the CPU. What is the central processing unit? The central processing unit is a digital circuit inside the computer. Its job is to process data by following given instructions. In simple words, the CPU tells the computer what to do and how to do it. What does the CPU do? Whenever you open an app, type a document, watch a video, play a game, the CPU is working in the background all the time, even though you can't see it. The main function of the CPU is to read instructions from a computer program, get data, process the data according to those instructions. This is how the computer produces results like text, images, sounds, or calculations. Okay, now let's identify the components of the central processing unit. The CPU is not just one single part. It is actually made up of three main components. They are arithmetic logic unit, CU, and memory registers. CU as in control unit. Let's understand them one by one. First, let's talk about arithmetic and logic unit, also called the ALU. This is the part of the CPU where calculations and decisions happen. Whenever the computer does math, the ALU is working. For example, 2 plus 3 is equal to 5. Addition, subtraction, multiplication, and division, all these are done by the ALU. The ALU also does logical operations. That means comparing values. For example, is 3 greater than 2? So whenever the computer checks whether something is true or false, the ALU is involved. Next, let's move on to the control unit or CU. The control unit is like the manager of the CPU. It does not calculate anything, but it controls and coordinates all the parts of the computer. It tells when data should be taken as input, where the data should go, when the output should be sent. It also makes sure that data reaches the right place at the right time and checks whether signals are received properly. So basically, the control unit keeps everything organized and under control. Now, let's look at the memory registers. Memory registers are very small storage spaces inside the CPU. They store data and instructions temporarily, only when the CPU is using them. Compared to the hard disk, memory registers have very low storage capacity but extremely high speed. That's why they help the CPU work very fast. So let's do a quick summary. The ALU does calculations and comparisons. The control unit controls and manage all activities, and the memory registers store data temporarily at very high speed. All three work together to make the CPU the brain of the computer. Alright, now let's learn about the evolution of the central processing unit or CPU. Over time, CPUs have changed a lot based on the electronic technology used to make them. The CPU can be divided into four generations: first generation, second generation, third generation, fourth generation. This classification is a simple version. In real life, computers are sometimes classified in different ways too. Now, let's go through each generation step by step. First generation computers. The first generation computers were used from 1940 to 1956. They used a technology called vacuum tubes. These computers needed about 18,000 vacuum tubes, and because of that, they consumed a huge amount of power. They produced a lot of heat. Specially cooling systems were needed because of this. Electricity consumption was very high. The size of these computers was as large as a room. You couldn't keep them on a table or desk. The execution speed was measured in milliseconds, which is very slow compared to today. They were also very expensive to produce and maintain. Examples of first generation computers are ENIAC, UNIVAC, and EDVAC. Second generation computers. Next comes the second generations. These computers used transistors instead of vacuum tubes. Because of transistors, power consumption was less than the first generation, less heat was produced, computers became smaller in size. The execution speed improved and was measured in microseconds. However, these computers were still very expensive to buy. Examples: IBM 7030 and CDC 1604. So compared to the first generation, second generation computers were smaller, faster, and more efficient. Third generation. Now let's talk about the third generation used from 1964 to 1971. These computers use integrated circuits, also called ICs. An integrated circuit means many electronic components packed into one small chip. Because of ICs, power consumption was less than second generation. Computers became even smaller, speed increased and was measured in nanoseconds. The cost of purchasing these computers was lower than the second generation computers. Examples include IBM 360 and CDC 6600. This generation made computers more reliable and affordable. Fourth generation computers. Finally, we have the fourth generation, which started from 1971 and continues to today. These computers use microprocessors. A microprocessor means the entire CPU is placed on the single chip. Because of this, power consumption became very low. Computers became very small, like laptops and smartphones. Speed became extremely fast. Speed is measured in millions of instructions per second. Fourth generation computers are also cheaper compared to earlier generations. Examples are all modern computers we use today. Up speed of the central processing unit. It means how many instructions the CPU can execute in 1 second. The unit used to measure CPU is Hertz. In modern computers, we used megahertz and gigahertz. So to summarize what we learned, the CPU is the brain of the computer and it has changed a lot over time. We learned that the evolution of CPU can be divided into 4 generations based on the technology used. The first generation used vacuum tubes. These computers were very large, consumed a lot of power, produced too much heat and worked very slowly. The second generation used transistors. These computers were smaller, faster, and used less power than the first generation, but they were still expensive. The third generation used integrated circuits. This made computers even smaller, faster, cheaper, and more efficient. The fourth generation, which we use today, uses microprocessors. These computers are very small, very fast, use very little power, and are affordable. We also learned The speed of the CPU, called the clock speed, is measured in hertz, and modern computers use megahertz and gigahertz. Overall, as technology improved, computers became smaller, faster, cheaper, and more powerful. And that's how the evolution of the central processing unit has shaped the modern computers we use every day. That's all for today. Thank you so much for watching. Remember, the first class is free, so you check it out and see if it's right for you. If you want to continue learning, join the full course for only 6,300, payable in 3 installments. I'm excited to help you grow your skills. Don't forget to like, subscribe, and hit the bell icon so you don't miss any updates. See you in class soon.